Now, please welcome our new next speaker from AWS, Anamaria Todor. Anamaria is a senior solution architect at AWS. She is working in various technical roles from freelancer, full stack developer, data engineer, technical lead, and CTO at various companies in Denmark, focusing on gaming and ads industry. She has been at AWS for over 2 years, working as a senior solution architect, focusing on mainly on life science and AI ML. Anna Maria has a bachelor degree in applied engineering and computer science and master degree in computer science and over 10 years of AWS experience. She is not when she is not working or playing video games. She coaching girls and female professional and understanding and finding their path through the technology. Anna Maria will explore exactly how much of jump there is from DevOps to MLOps. Then we will examine the best questions and make a smooth transition. Don't forget to share your questions to Anna Maria and please welcome Anna Maria. Stage is yours.
Thank you, Dimitro. Hello, everyone. As Dimitro mentioned, today we're going to talk about how to do the jump from DevOps to MLOps, and we're actually going to try to measure how much of a jump it actually is. And just to put a face to my name, so my name is Anamaria. I'm a cat lover. I actually have a cat, and I have had it for 8 years. Her name is also Anna. Don't judge. I'm also a gamer, and I've been playing video games ever since I was 4 years old. I'm not very competitive anymore, but as you can see, I'm still trying to keep up. And professionally, I've been working with AWS for over 10 years, and also at AWS for 2 years and a half. Main area of expertise is big data and analytics, but for the last 2 years and a half, I have also focused on AI and ML. So before we even get started, I want to be clear about a few things. It is completely possible that you know a lot about DevOps already, since it is a pretty established subject. So some of my slides will seem pretty familiar. I do promise there is content here that will be new to you, but I sort of have to set the scene or a baseline for some of the people on the call who know less about DevOps. All right, with that disclaimer in mind, first up is, of course, DevOps. So in many ways, DevOps built on the foundation of Agile to become a standard that we all reach out to in our everyday work. It first surfaced as a concept roughly 14 years ago, so in 2008, when cloud computing was in a very different spot, right? I mean, AWS was at the very beginning offering a few services, and Azure and GCP were not yet available, at least not publicly. So the majority of companies maintained their own infrastructures. Developers wrote code and relied on sysadmins to deploy the code using, at scheduled intervals, often weeks or even months apart. And container technology hadn't been invented yet. Applications were largely monolithic, and serverless didn't exist either. Everything from the application itself to the actual engineers was centralized. And all of that changed in a little of over 10 years. Sometimes I'm actually amazed looking back at those times that we were surviving and even more actually thriving in that centralized environment. And in the years since DevOps attempted to answer the conflict between developers and operations engineers, it has become a sort of a catch-all term. It can mean 100 different things to just as many people. For some, it's about continuous integration and continuous delivery, and so CI/CD. For others, it's more around deployment frequency and making sure that there's tests and security gates in place before you can actually release the code. And for others, it's about the organization, Maybe they've added a platform team or a DevOps team, or maybe they have created a central engineering structure team that focuses on the separation of concerns, and then have different feature teams that then manage the development, deployment, security, and maintenance of everything else, right? Whatever the interpretation, though, and there are many, as you can see, what is important is that there isn't a universally accepted standard of what DevOps is or what it looks like in practice. It's probably more of a philosophy than anything else, a sort of methodology or framework people can use to configure or customize their specific circumstances to modern development practices. And the software development lifecycle, or SDLC, has actually been around for a very long while. It's been around since the 1960s. If you think about it, it's almost as old and ancient as the color television and the telephone. And in all this time, it stayed roughly the same. I mean, of course, with Agile, we kind of, taken it and bent it into a circle. And then when DevOps came along, we kind of twisted that circle into the infinity loop that you can see on the slide. And if we were to unbend or flatten the loop again, there are tools in the AWS suite of services to cater for all developer needs, from the traditional SDLC tools to intelligent tools for improving code quality, or tools for enabling infrastructure as code at different layers of abstraction. Either way, the one characteristic of DevOps that I think we can agree on that is the most important is that it is sort of attempted to capture all the challenges of the software delivery process, which also kind of led to spin-offs, right? So you have, for example, DevSecOps, which was the first and probably the most important because it added the ever-important security layer to the initial idea. Then we have GitOps, we have DataOps, and we also have, of course, MLOps. And it might be that you are sitting on a team right now that is doing DevOps already and have the need to make the jump to machine learning operations. And you'll hear your manager or product owner saying, you'll be fine, right? It's just more of the same. At which point, I do hope you'll make the stat pug face right here and push back on your management, because machine learning operations is definitely a bit more than DevOps. So while DevOps usually focuses more on the source code itself, MLOps brings two additional layers, that of the data and the machine learning model. Moreover, the code itself and the data are independent. A lot of times you actually are required to do additional cleaning and massaging of the data to transform it in order to do the training of the machine learning models. Which also means that from an MLOps versus DevOps perspective, you suddenly have a lot more stuff to track or to keep track of. So you need to look at the data provenance and have a data lineage in place. You care about the data sets and how they're versioned. You also care about the models themselves and how they're versioned, how they perform, together with the hyperparameters values that they have been trained with already. And lastly, of course, you have to look at the model deployment workflows themselves. So MLOps comes with a lot of additional complexity, right? Taking a step back and looking exclusively at the machine learning solution lifecycle, usually you want to begin with framing a problem. So you're looking at a business problem and you try to assess whether, hey, is this something we can actually solve with machine learning? So usually the first step to that, and especially if you're looking at deep learning models that use a lot of data, is that you start looking around in your data lake or data mesh and figure out if you have enough data to actually solve the problem with machine learning. If you don't, you might have to go with building synthetic data sets. Once you do have the data, you do need to integrate it into your data storage solution and do data preparation and cleaning. And only then you can start looking at actually preparing the data for training and tweaking the machine learning model. At this step, you might want to massage the data further. You might too want to reduce its dimensionality. Maybe you figure out that the data is correlated with some of the features are correlated between themselves, so you want to minimize that. Once you're happy with the data, you start doing training. You start tweaking the hyperparameters that are available for the different models. And once you are happy with the evaluated model, you have a choice of saying, does this meet my business goal in a satisfactory manner, or do I need to go back to the drawing board and do everything again the same? If the answer is well, yes, this is where you actually deploy the model. And this is where I would say traditional CI/CD comes into the machine learning solution lifecycle. And of course, you want to close the loop as well with monitoring and debugging. But traditional MLOps, or what it tries to do, is to actually extend the CI/CD part from the model deployment side itself to the whole solution lifecycle. Which also means that machine learning operations, just like DevOps, is a combination of people, technology, and processes. It sits somewhere in the middle. But again, tech is only the tip of the pyramid. You actually need to start from the bottom up. People are the foundations of machine learning operations. And a classical anti-pattern in MLOps is the full stack data scientist, where we expect the current data scientist to kind of be a know-it-all and be able to deploy an end-to-end solution. But a data scientist is not a rocket scientist, and this is unlikely to work. In reality, we need a diverse team to deliver the end-to-end solution. And we need the collaboration and culture that allows and encourages the team to work together. And of course, people implement processes, all the processes that I mentioned in the machine learning development lifecycle. And technology it sits at the top because it is the way in which these processes get delivered, enabling you to actually generate business value. So with that in mind, let's look at some best practices for doing a gracious switch from DevOps to MLOps. So looking at the machine learning lifecycle again, there's basically two subsets or two phases that you can split the lifecycle in. The first one is the pilot phase, and this is the one that is the closest related to the business problem. So this is where you look at the data itself, whether it can solve the business use case. It's also where you pick what model to use, and basically, if you get any return of investment, this is where you evaluate it. And if you're happy with this, then you get to the operational phase. And this is where you think more about, do you implement these models at scale? How much do you have to scale? What's the performance that needs to be achieved with this model? Is it something that will serve a product in real time, or is it something that will just enrich data over the night for maybe business units in your company? Also, this is where you think about consistency and training the model in consistent manner. So making the jump from science to production actually requires you to assure that you have, first of all, some flexibility. You need to be able to accommodate any framework. So maybe that could be TensorFlow or PyTorch or the next big thing that's going to come. Then you need to have reproducibility in place. You need to be able to recreate or observe past experiments easily, because 90% of the data scientist's job is exploration and retrying all theories. Of course, you want to be able to reuse source code and the machine learning pipelines. And this is not just for minimizing costs, but also to avoid inconsistencies. You'd also want to have scalability, to be able to scale your resources out of the box and serve everything in demand, because with today's production environments, you never know when your service might become very popular and you just need to add new resources over the night. And of course, in some industries, more than in others, auditability is also a concern. So legal departments should be able to audit logs and versions and dependencies and data artifacts. And this applies to machine learning as well. Just because it started in an experimentation environment, it doesn't mean that the end product should not be fully auditable. Lastly, you also care about consistency, because machine learning operations consist of multiple environments, and the foundation needs to eliminate variance between environments. And luckily, AWS has quite a broad and deep set of services that can help you in your machine learning operations journey. Of course, there's the base layer, which is more about the hardware and the hyper-optimized hardware for the different inference and training tasks. And there's high-level services where you only bring the data and you leave the heavy lifting to basically the AWS services themselves. But then there's also the middle layer that you can see here in the middle. Yes, that's called Amazon SageMaker. So all the sub-services of Amazon SageMaker are designed to actually help you on the MLOps journey and automate as much of it as possible. Of course, SageMaker is also an integrated development environment, but you can use it and basically mix and match any of the sub-services that are available in it without worrying too much about the IDE. So let's explore in the next few slides how you can actually leverage these AWS services as well as others in order to adopt machine learning operations and to do the switch from DevOps to MLOps. So in talking with various customers, we've actually tried to come up with what we call the MLOps maturity models. And it includes several stages, namely 4. So the initial stage, the repeatable stage, the reliable stage, and the scalable stage. And I'm not going to spend a lot of time on this slide because I'll go into each of them in detail in a second. But before even going there, I actually believe there's one additional stage that is worthy of mention, that is, not part of the official maturity model, but I think it's very relevant for a lot of customers, and that is the working locally stage. So believe it or not, but this still happens at a lot of data science departments, where data scientists manually collect and label unstructured data. They're still working on their laptops and running the jobs on a local server. They use pretty much the same tools, the modern tools that they would use in the cloud. So that includes Python and open source libraries, deep learning libraries as well. And of course, the actual end results are directly proportional with the amount of effort that the data scientist and the data engineer puts in here. And working locally is fine, but it's also pretty bad. And if I were to compare it to something in classical DevOps, it would be as if, in this time and age, you would be deploying something to production by SSHing on an instance and pulling the code from Git manually. Kind of the same thing from my perspective, right? Because it's very hard to maintain quality at scale if you manually collect and label the data. And then your laptop might be powerful, but it definitely has a limit. And especially if you want to move fast, you will never have enough local resources to scale. Moreover, even if you have the most robust library environment locally, you'll encounter a lot of trouble if you want to, share your code with the other data scientist, your best buddy, because again, it has very limited portability if you approach it like that. And then if everything sits on a local machine, there's no easy path to production. So at a minimum, to do the right thing when it comes to machine learning and machine learning operations, the best thing you can do is actually, go to the initial phase in the machine learning process, which is to establish an experimentation environment. So during this phase, the data scientists are able to work in the cloud to experiment, and that means build, train, and deploy models in an AWS environment using a data science workbench. And yes, in the slide, I'm showing Amazon SageMaker Studio, which is a Jupyter-based environment. But depending on your needs, you can also host your own Jupyter environment. Or there's also the older SageMaker notebooks that have a bit more flexibility around security that you might want to use. So there's a lot of options available. And in addition to this, You can use other services to process the data, and this includes MapReduce frameworks such as Amazon EMR or AWS Glue, or also Presto engines like Amazon Athena. You have a lot of flexibility on how to actually clean up the data before you experiment with it in the machine learning environment. Last but not least, this is also where you bring versioning into the picture by using, in this case, AWS Code Commit as a code repository. But of course, you can use other tools of choice. Let's look at the repeatable phase now. So now that you've figured out how to experiment on AWS, the next step is to create automatic workflows to pre-process the data and build and train the models. This is where actually data scientists start collaborating with the DevOps engineers in a separate environment to build robust and production-ready algorithms and source code. And the generated models are usually from this point on stored into some form of model registry. And very important at this stage, this is also where the separation of concerns comes in. I mean, you can already see that the AWS environment is split into multiple accounts. So first and foremost, at the bottom, we have the data lake account that stores all the ingested data from various sources. Then you have the experimentation account, which is just a variation of the initial phase that I presented before, with the difference that the data is now coming directly from the data lake or data mesh. Then you have a development account or dev account. This is basically the very beginning of a production environment, which we'll see in the near future. And of course, the tooling or automation account at the very top that will host the repositories, the CI/CD pipelines, the SageMaker model registry, and Elastic Container Registry for custom containers used for training. And because the data lake is the single source of data and the single point of truth, the tooling account is only for the code and the containers and the artifacts themselves. But in order to make this jump from the initial phase to the automated phase, so to automatic deployment, of course, you have to put a lot of standardization in place as well. So this means standardizing the pipelines, standardizing the code repositories, and the data structure. So this is what I'll try to discuss in the next few sections. So let's look at pipelines first. So what should a machine learning pipeline actually consist of? So it consists of a set of steps that are responsible for all the machine learning process. So that means pre-processing the data, training, using models, everything that I've already presented. And each step should perform exactly one task. And it should be abstract enough in the sense that, for example, you should be able to pass different column names as input parameters in order to, of course, enable reusability. You can implement pipelines with already familiar tools, such as, for example, AWS step functions, or maybe you're a fan of Apache Airflow. That's also a possibility. And you can also use the SageMaker pipeline. On this slide, I am illustrating both step functions and SageMaker pipeline. Now, depending on our use case, you can separate the machine learning pipeline in two main types. You can have a training and an inference pipeline, or you can merge them together. Again, it depends very much on what you actually want to do and achieve. And in order to ensure that your machine learning pipeline is robust, we usually recommend that you do a multi-branching repository strategy in your development account. So, and that also that you enforce deployment only through the CI/CD pipeline, which means that now you have two possibilities. You can allow the data scientist to use a feature branch to develop new functionality, and then they would only be able to deploy it to a test environment by merging in the development branch. So this is one option. Another option would be to allow the deployment of machine learning model pipelines per feature branch. Both are shown on the slide. And again, there's not necessarily a one-size-fits-all. It's more related to your processes and how you want to approach it. Now, looking at the code itself, as I mentioned before, you also need standardization around this, because this would enable your data scientists and DevOps engineers to work better. And you could also incorporate automatic validation and building of custom containers in the code itself. This slide illustrates a possible repository structure for both building, training, and deployment. But again, it's something that is highly suggestive. Yours might look different. It's just a starting point and something to consider. Same goes for the data structure. So if we assume for simplicity that your input data actually lands in a bucket, you're in your MLOps bucket, even though that's not necessarily true, because usually the data is in the data lake. We've already established that your data scientists will actually require to merge their code into the main dev branch in order to trigger a run of the machine learning pipeline. So what you can do at this point is to actually ensure that the pipeline creates a separate subkey automatically under the MLOps bucket here. And this structure enables the data scientists to audit and query past data, so past deployments and runs, because they're stored separately and nothing overwrites. No run and no use case actually steps on each other. However, as you can see, this approach might generate a very high amount of data. So therefore, it would be good to have a data lifecycle strategy as well. So maybe one thing you could do is, for example, to delete the data once each feature branch has been merged, either in dev or in the main branch. So far, so good. Let's look at the reliable phase. So what have you done so far? You have an experimentation environment. You also went through the process of generating models automatically with machine learning pipelines. Well, now you need to also test them in an environment that is very close to production. So therefore, what you're doing in the reliable phase is that you are introducing the automatic testing methodology for both the model itself and the triggering infrastructure in an isolated pre-production environment that looks very similar to the production one. And of course, after a successful run or test, the models can be deployed automatically to the isolated production environment, or you also have the option to put a man in the middle, so to do manual evaluation and approval of the specific pipeline. And if this was not complex enough, we're at the last phase, the scalable phase. So now that you have all your machine learning model in place, right, it's reached production, you're happy with the results, you need to start thinking about scaling out to support both multiple machine learning models and multiple data science teams. So this is where you want to start thinking about templating, right, and turning your current solution into a template. The problem can be complex though, because data science teams can have access to different kinds of confidential data, not to mention that the multiple business units might have different charging needs. They could pay a separate bill for everything. So you need to somehow enforce the separation of concerns. So to enable the easy creation of machine learning operations accounts, you can introduce yet another account, the Advanced Analytics Governance account that you can see here on the slide on the left side, which would allow IT members to catalog, instantiate, and decommission machine learning accounts on demand. So pretty much through like a account vending machine, but just for machine learning operations. And that would kind of be all the phases of the machine learning DevOps process. Should you burn steps and go through all of them? I think the answer is that it depends. And it depends on how much machine learning you'll actually do in the next years or so. How much do you want to scale? Are we talking about tens of models, thousands of models, and so on and so forth? And your already existing organizational complexity. But so far, we've looked a bit more at best practices from a technical aspect. So let's also spend like the last few minutes or so to talk about the cultural part. So, if you want to do machine learning operations, should you force machine learning on DevOps people, or should you force operations on data scientists? Well, I think the answer is actually neither. And here again, I would revert to the general AWS wisdom. What we usually recommend is that you do two pizza teams. So these would be multifunctional teams that can serve a project end to end, and they shouldn't be bigger that what can feed, what can be fed by two pizzas in one sitting. This approach would allow you to empower the teams to make their own decisions because you'd have all the elements in there available to all the expertise in one place to really take the decision. And it would also minimize social constraints because if we look at Conway's law, which says the structure of software will mirror the structure of the organization that built it, it means that having these kinds of smaller distributed teams would lead to modular architecture, so microservices. It also means that you would discourage silos in the organization. And I've had a lot of conversations with data science departments everywhere. And usually what I hear is that we can't really proceed because we're being blocked by the data. So then I go and talk to the data engineers, and they're more like, oh, yes, but we're being blocked because the data pipeline doesn't work because that relies on operation, and so on and so forth. You can see how this is a vicious circle and can become one very easily, right? But then, of course, it's important to enable your teams to work together. As I said, have them be as multifunctional as possible, and also make sure that each persona has a clear view on their purpose on their team. And to sum up, a robust machine learning operations foundation can increase speed to value and reduce costs, and it can enable data scientists to focus on innovation. But we usually think that everything that has to do with software development should be a straight line, but it never is, ever. It rather looks more closely to this. And your machine learning operations journey will be roughly the same. But hopefully, this session shed some light on how to extend your foundations from DevOps to MLOps gracefully and without shedding too many tears. So I want to thank you for listening in. And also, if you have more questions about MLOps, feel free to reach out to me on LinkedIn. And also, please scan this QR code to provide feedback on the session. I try to improve my presentation skills and the content, and I can only do this with your help. And now I will open the floor for questions.
Your presentation skills awesome, actually. Thank you a lot. So
Thank you.
really great, interesting presentation. A few questions from my side. The first one, you mentioned about AWS. It's normal because we
Yeah,
have AWS conference, and you're a
yeah,
senior solution architect there. But maybe you know some partners of AWS, maybe on your marketplace, which
yes,
also providing tool set for MLOps as well. Maybe you can share with community these
yes.
names.
A very robust partner that I encounter a lot in my discussions is, of course, Databricks. And they
Hmm.
do have, I think they're actually the creators of MLflow, which is also used separately from the Databricks environment as an open source framework. And I see that a lot. A lot of my conversations also revolve around how you can integrate SageMaker with MLflow. And of course, you can do that in various different ways. And why I believe Databricks is also great because it's also because it lowers the barrier entry for people coming from a more of a data engineering background, and it's basically very easy to make the jump from doing a MapReduce in Databricks to doing a bit of machine learning as well. So
Hmm.
definitely one partner that I can recommend. Other than
Hmm.
that, I focus a lot on more like open source tools and frameworks, so nothing else comes to mind on the spot.
Hmm. All right, yeah, Databricks, they provide a really great solution for that. Also, you showed the responsibility model, who responsible for what, right? And am
Yeah.
I understand correctly that data science guys should create, configure all of this pipeline for this data ops pipeline,
I
let's
think
say?
I think they should have a say in it. So of course it depends on the size of your organization as well. So for example, before joining AWS, I was part of a scale up where we had a pretty robust team, but it wasn't necessarily enough people to do like a very clear split between DevOps and data engineering and data science actually. So we were merging everything together, right? So we were
Mhm.
wearing multiple hats. My recommendation is, especially for bigger teams, is to basically have the multiple competencies together. So maybe have multiple data science team and the DevOps lead that jumps from team to team to sort of advise on the DevOps angle. Where I think the data scientists should have ownership is definitely over the machine learning pipeline. And then I think the DevOps team, or rather the person with the most DevOps expertise, should be more at the higher level, at the CI/CD level, and especially should come in where you're scaling across different accounts and you want to reproduce this at scale, right? So that's where you need to talk more about DevOps in the initial phases, and especially you can achieve so much just by going away from local and wrapping your head around scaling using other resources in the cloud. I think that's like the essential step. And then everything else can come along in years. I don't think that's a problem.
Mm-hmm. Yeah, that's true. One more question from community. Do you use any
Yeah.
specific infrastructure as code framework for building ML pipeline,
All
like
right.
Terraform? Yeah, or
Yeah.
Ansible, like DevOps using? Yeah.
Yeah. So, um, well, mostly because I come from AWS, I do use the high level services that are provided by AWS. So,
Mhm.
SageMaker Pipelines is basically Python code at a very high level, which allows you to define your machine learning pipeline. And of course, if you're looking at more generic solutions, you can also use, as I mentioned before, step functions because they're more generic and you can use them more widely across different tools. But essentially, it's more like you can integrate whatever tool you choose to use. You might want to go with something more open source. You can integrate it in your infrastructure as code product. You'd probably have to do a bit more customization. So looking specifically at Terraform, I don't know, but if you'd want to pick maybe like an Airflow instance to manage your training jobs, you could potentially spin that up in code. It's just that you'd have to do additional configuration. Or again, you might use the managed version from the different clouds if they're available. But those usually also have constructs in Terraform that make them available. So the answer is yeah, you can probably do it. How complicated it is probably depends on what tools you want to choose.
Mm-hmm. Yeah, makes sense. Another question: any service suggestions for data versioning in AWS?
Yeah, I think. I mean, of course, if you're looking at your data lake, usually it sits on top of S3, right? And S3 already has versioning available out of the box. However, I would say that's maybe not a mature enough solution to look at, right? So I would actually look in the partner space for enriching that with additional information.
Mm-hmm. Mm-hmm. Yeah, S3 really has this option, and we can rely on this solution. Yeah.
Yeah.
Uh, can there be a solution that model that you got produced is not matching with expectation of customer? How do you actually avoid such situation? So we release something, but it's not uh, have some problems, mistakes. I don't know. Um, so
Yeah.
how we deal with that? Some rollback strategy.
Oh yeah. Well, that could be a very complicated question. But I think the way to avoid it is definitely setting some very clear success metrics for what would make your model successful, because you shouldn't bring something to production unless it actually meets the business needs in the very beginning. So work back from the use case, validate it with your own customer as soon as possible, and yeah, don't bring it out there until you're actually sure about that. Of course, that's one aspect. The other one of it is that models do become stale across time, because usually the data you train them on, they're a snapshot in time, right? It's how the world look like at a specific point, but reality changes all the time. So that's why it's important to have monitoring in place, and especially monitoring for drift. So here you look both at data drift, so looking at the quality of the data and if it looks the same as it did in the beginning, but you'd also look at the model drift itself. If the model itself has started underperforming for some reason, or whether it had some form of bias incorporated that you didn't notice, because let's admit it, deep learning models are pretty much black boxes. So yeah, if that's the case, with monitoring in place, you'd have to go back to the drawing board and do a new collection of data to reflect the new reality, do retraining, and then ensure that the new performance of the model is actually on par with what your customers expect.
Mhm. Okay, it probably was our last question. So, could you please choose a few questions which you think we should provide some presence from our organizer? What question do you like? So, what do you prefer? So, we should send some presents.
I don't understand. What do you mean?
Yeah, yeah, yeah. Could you please choose a few questions which you think is great or you like them, and after that we will send some presents to after of these questions from
Okay, so
AWS.
any question around technology or?
I'm just ask you a few questions and
Ah,
just
okay.
yeah, just choose yeah a few of them which you like.
Yeah, all right.
So we're asking about uh, the versioning, right? It was
Yes.
one question. We asking about infrastructure as code, and we asking about rollback procedure. So, which
Yes.
of this question you think is a great one, and we can send some presents to the after of the
Ah, okay.
question.
Yes. I understood now. I'll pick the versioning one, because I think that's where we can make improvements, and I'd like to actually hear more feedback on that. If anyone, if the person who asked it can provide more on what they're looking from a versioning system, I'd love to hear that.
Mhm. Uh, yeah, I think they can provide more questions in our Q&A session. Okay, in the chat. So thank you
Yeah.
a lot for your presentation.